Hello everyone, let's continue our discussion with the CDMA. Okay, in this video we're just talking about how the encoding and decoding process in CDMA works. We're not talking about the whole whole CDM systems. Okay, just to give you an idea how it works. All right, so first of all, in CDMA, each user is assigned with unique code, chipping sequence. It is called chipping sequence, so that all the users can communicate by using the same frequency and the same time without interfering to each other. And one important thing is that the codes have to be orthogonal. Okay, so if the codes are orthogonal, so all the users can communicate by using the same frequency and the same time slot without interfering to each other. Or if there is interference, it is very minimum. Okay, all right, so now we talk about the encoding and decoding process. For more, clear explanation, we are going to we're going to do it in the example after in the next slides. Okay, so in the encoding process, we have inner product. Okay, so between the original data, let's say the bits or the symbol that is going to be sent and times the chipping sequence. Okay. Now the decoding part, again we take the inner product, but then we sum it together. Okay, inner product of the encoded data and the chipping sequences. Okay, so the encoded data is already in the sequence. Okay, sequence data. It's not just one or zero or minus one. And then we take the sum and then divide it by the number of the chipping sequence. Let's just directly continue to the example. Now we take the example of one user. Okay, so now let's say we are going to send, the sender is going to send data or bit symbol 1, and it is assigned with this symbol chipping sequence 1 1 1 minus 1 1 minus 1 minus 1 minus 1. Okay, so we just take the inner product one by one. 1 times 1 is 1, 1 times 1 1, and so on and so forth. So we are end up with the same the same sequence as the chipping sequence, because we are multiplying it with 1. And if we send minus 1 instead of 1, then we have the opposite of the chipping sequence. Okay, so minus 1 minus 1 minus 1 1 minus 1 1 1 1. Okay. All right, now at the receiver, how we recover this is by taking the inner product of each, its sequence data, okay, with the chipping sequence. Okay, so take one, and then we sum of all of them. Okay, so 1 multiplied by 1 is 1, 1 plus 1 plus 1. So basically, minus 1 times minus 1 is also 1. 1 plus, and so on. So we end up with 8. 8 divided by the number of the sequence is there is also 8. So we end up with 1. Okay. And similarly for the other slot, okay, so we are taking the multiplication minus 1 with 1 is minus 1 minus 1 minus 1, and so on and so forth. Then we end up with minus 8 divided by 8. Then we end up with minus 1. So we can recover the data at the receivers. All right, but this is not really useful yet, because we are still using only one user. Now let's take the example, another example where we have two senders, okay, and each of them have different chipping sequence, okay, and I assume that they are orthogonal to each others, and they send different set of data. Okay, in the first slot, slot 0 is 1 and 1, and in the slot 1, the sender 1 send minus 1, and the sender 2 again send 1. Okay, so in this let's do it one by one. Okay, in the slot 0, this is quite straightforward, because we can just directly sum the both of the chipping sequence. 1 plus 1 is 2, and then 1 plus minus 1 0, 1 plus 1 is again 2, minus 1 plus 1 0. Okay, and then 1 plus 1 again it's 2, and minus 1 plus minus 1 is minus 2, minus 1 plus 1 0 and minus 1 plus 1 0. Okay, now with this we have to multiply by minus 1, so minus 1 plus 1 is 0, minus 1 plus minus 1 becomes minus 2, minus 1 plus 1 is 0, minus 1 plus minus 1 is 1, 1 plus 1 is 2. Okay, so minus 1 plus 1 0, minus wait, minus 1 plus 1 0, and then again this is 0, 1 plus minus 1 0, and then this is 1 plus 1 2, and 1 plus 1 is again is 2. Okay, so this is the uh, the sum of the channels in the senders together for the sender 1 and sender number 2. Okay, so now at the receiver, let's say at the receiver 1, the internet receiver for the sender number 1, we can again do the same, take the inner product, okay, between the channel sequence with the chipping sequence of user 1, sender 1. So we, okay, for the slot 1, 0 plus 0 times 1 is 0, 0 minus 1 and 1 is minus 2, so again it's 0, 2 minus 1 is becomes minus 2, so and then plus 0 plus 0 and minus 2 minus 2, so we end up with minus 8 divided by 8, so we get minus 1. All right, so now for the slot 0, 2 times 1 is 2, 0 plus 2, oh sorry, plus 2 plus 0, and then minus 2 times minus 1 becomes plus 2, and then plus 0 plus 0. Okay, so now we end up with 8 divided by 8, then we get 1. So now using the same code as the sender, at the receiver number 1, we can recover the data that was sent from the sender 1. Okay, so now we can see that this is this is more useful. So again, remember that this can work if both the sender or the all senders have the the codes are orthogonal to each others. So I think that's it for the CDMA. We'll continue next video with the starting with the 802.11 or wireless LAN. Okay, so see you again in the next video.